Good morning, everyone. Today's topic is engineering tribology. Today's subject is engineering tribology, and my name is Dharma Teja, and roll number is 20951 314, and topic is extreme pressure lubrication. Introduction. The lubrication of two surfaces which are sliding past each other may be obtained by interposing between the surfaces a layer of some material which can be shed without causing any damage to the surfaces. The layer firstly prevents opposing the aspects coming into the metallically contact, thus welding and tearing. Secondly, it serves to reduces the friction between the surfaces, though this is a secondary requirement. In a simple system consisting of two surfaces moving past each other in the presence of lubricant, there are several lubrication regimes. When the surfaces are separatedly by a relatively thick film of fluid, which usually occurs under the conditions of low loads and high sliding speeds, then the metal to metal shear is replaced almost entirely by fluid shear, and thus the frictional behavior is determined by the fluid properties of the lubricant. In the region the coefficient of friction is very low and surface wear is negligible, the lubrication under these conditions is termed hydrodynamic. Extreme pressure lubrication. The term extreme pressure lubrication is perhaps misleading since presumably the pressure per unit area on the actual contacting surface does not change with the loading. Rather, the increased pressures result in increased contact areas. This concept was explored by the Boden and Riller, who employed a dynamic thermocouple of a metal glass cylinder sliding over the surface of dissimilar metal to show that even in well lubricated systems, surface temperatures in the contact zone between sliding metals could approach the melting point of the metal. For these reasons, it was suggested by Bowden and Tabor that such extreme pressure lubricants might over accurately be termed extreme temperature lubricants. The property of the certain elements to arrest the scuffing of metals and thereby increasing the load carrying capacity of oils was noted in the early 1920s with the development of hydraulic gear in the automotive industry. An immediate need was created for the extreme pressure composition of the extreme pressure film. The work by Mogley Element 6 in the 1931 clarified the extreme pressure situation. They used a simulator rear angle test rig and showed that all cases where sulfur was the active ingredient in the extreme pressure oil, the steel surfaces were covered with a black film with the analysis indicated to be iron sulfide. Later, several investigators adopted the approach of pre-treating the sliding members of test rings with the artificially chemical flames and comparing the results with those obtained use untreated members. Campbell developed a very elegant method consisting of a polished metal plate upon which was placed a slider resisting against a stop on the plane, which was tilted by a motor. When the slip occurred between the slider and the plate, the movement of the plane was stopped. Hence, the coefficient of friction could be calculated from the angle of the inclination of the plane. When the sliding was integrated, films of iron sulfide were deposited on the plane and slider by the impression in the sodium sulfide solution. This is also one of a pressure system of lubrication. This is one of the type. Effect of loads, SPPFD and temperature on extreme pressure flame formation. Artificially produced radioactive materials have been available in the quantity for only a few years, but in time they have been used as a tool in many fields of research. The radioactive isotope of an element has the same properties and hence follows the same chemical process of responding stable element. This enables the isotope to act as a radioactive ladle and allows the course of a reaction or in uptake of an element to be traced. In this way, radiochemical methods have been found to be particularly useful in the field of extreme pressure lubrication. 20, 21, 24, 26, 28, 34, 41, 45. The first attempt to use a radioactive isotope of sulfur S35 for this purpose was made in 1944 by Clark, Gallo and Lincoln. 06 was investigated the extent of sulfide flame formation on various metal alloys using tagged sulfurized olefinic hydrocarbon. Antics of extreme pressure additives on the iron surface. The previous section dealt with the mechanism by which the extreme pressure actives reacts with the metal surfaces to form an inorganic and anti-scalar flame reaction. Kinetics is concerned fundamentally with the rate of chemical reactions with all factors which influence the rate of reaction, and with the explanation of the rate in terms of the reaction mechanism. Greenhill described the extreme pressure reaction as controlled corrosion process, and subsequently much of the nearly research into the kinetics of reaction between the sulfur and compounds and metal surfaces, and the long periods on the owning the coating of the ferrous sulfide. This is also one is explained. Thank you.